many of you are practicing microservices or any shape and form of that? Okay, cool. That's good to see. Do you know that you're doing it right, or that's the reason you're in this talk, I guess? Okay, awesome. So yeah, I hope at the end of this talk, a lot of your questions, concerns is elevated, and you know how to make better microservices architecture. Obviously, microservices architecture is the buzzword, and nowadays there's a lot of confusion. There's a lot of clarity, also a lot of places. But yeah, I mean, it is the architecture of the future, in my opinion. And if you practice it right, it would help you in a lot of different forms, not just technical, but even from an organizational point of view. I think it tries to tackle some of the pain points. So, okay. So before we get into the presentation, shameless plug on where I work. I mean, I'm part of Zaloni. What we do is we help clients build their data lake. We have a big data product. So we help them using our product to manage their data lake. We have professional services to help you with solutions and all that stuff. So if you have anything on that front, feel free to contact me. I have email addresses and all this stuff at the end of the slide. So you must be thinking, what is in it for me? Why should I be here, right? So first of all, we'll just quickly go through what's the history. People think microservices is something very new. Netflix and Amazon and some of those companies have tried to build those things, but it is not. I mean, it has been coming. It has evolved over the years. So we'll just know that. We will try to see what is microservices about. I mean, if you bring 5 people into the room, and they will get 7 different definitions. So we'll try to stick to one, and I think that makes sense. A lot of confusion on SOA, is it SOA? Microservices is SOA, because a lot of things which microservices talk about is very similar to SOA. Is it SOA? Is it not? And we'll see. Obviously, with any technology, technologists want to hear what is the value add? Why should I use? Why should I practice it? Right? So we'll see some of that. Obviously, nothing is complete then, because we are in a technical presentation. So I'll talk about a sample reference architecture, which I have consolidated over the years. I've used some tools. I'm going to talk about those tools. Obviously, it's an opinion. If you find something different, absolutely. But yeah, so we'll talk about a reference architecture. You will see microservices bring a lot of choices into the mix. Developers, technologists, QA have a lot of choices to make, but make the right choices. And there are some, as with anything else, there are some principles. If you follow them, you will most probably make the right choice. So we'll talk about that. And at the end, is everything so awesome as it looks like? So we'll try to see if it really is. So a bit of time travel quickly. So obviously, late 2010s, Netflix, Amazon, you hear a lot of microservices work. They are doing actually a lot of microservices work over the years. Netflix obviously is a pioneer in that. And then came 2000s. I mean, late 90s, 2000s is where SOA kind of came into the picture. People wanted to do SOA because they wanted to reduce cost, make it efficient, make it reusable. A lot of continuous integration, deliveries. Agile actually rose, so they thought SOA is the answer to all that stuff. And before that, it was web services, which Microsoft with TCOM, Corba, and all that stuff, you must have, I guess a lot of you have worked on those technologies. And before, if you go a bit further, like in 1980s, some of these languages are, if you see, I mean, you can build microservices architecture on top of those also. And if you go further in 1970s, there's something like, if you look into actor model and all that stuff, it is kind of microservices. It's about telling okay, do one thing right. That's the goal. That's the mantra which people try to say when you see or hear microservices. So as I said, you bring 5 people, you get 7 definition. I stuck with Martin Flau's definition because he was the one who kind of evangelized this concept and is trying to say, okay, yeah, this is a good technology to work on. So if this is his definition, microservice architecture, I'm just reading it out, is an approach of developing a single application. The highlighted ones are the keys, because that's what we will be hitting on. Suite of small services, small services, running in its own processes. You will see why it needs to be running the own processes, not like a lot of services in one process. Obviously, because they're running on their own processes, they're distributed. You need to communicate with each other. So there has to be some mechanism, most probably HTTP. These services are built around business capabilities. So now the thing is like, now I have services. I know that I want to build services, but what my services should be. I mean, how do I know this is the right service? This is the boundary is the right boundary for my service. So you want to create those services around business capabilities, and you will see how. Independently deployable, because the problem with, so one of the things microservices try to hit on is the monolith era. Like you had big applications, WebLogic, WebSphere, IIS. You build big web applications or whatever applications. And so you deploy all them as a unit. But over here, because it's microservices, I mean, there are a lot of services, most probably. So you want to deploy them independently so that you get a lot of the benefits of smaller cycles, less footprint of change. So that's the independent deployable part. You want to make it automated because it is complicating. Microservices architecture is not simplifying your space. It's not simplifying. It's not a architectural pattern to simplify things. Obviously, you will get simplification and agility in a lot of things, but when it comes to deployment and monitoring and all this stuff, it actually complicates your space because you have to do there are a lot of processes to monitor. So automated deployment, you will see automation is key. Oh, sorry. Then one of the things is like different programming languages. You will see like people can now start using whatever language they want to for their service, and we will see if it is good or bad. And because of that, because now I have a service, I should be able to use different storage technologies underneath the way I persist my data. So before we get deep into the microservices, a quick thing of like, what is SOA and what is it? I mean, how does it relate to SOA? So in SOA, if whenever you have done, generally we used to talk into like, okay, there's a database, there's a DAO layer, there is a business layer, there is a presentation layer. It's kind of horizontal. So if you were in an industry, in airline or healthcare or anywhere, it's the same thing because you have 3 layers. There is not much to differentiate on top of it, right? And you're building, and most probably those 3 layers are done by 3 different teams. So that is one of the key. Like SOA was trying to, although it was talking about services, but still it was saying, okay, there is a common database layer which everybody should talk to and all that stuff. So it's going the other way around. Microservices talk about verticals. So it says slice it out, give everything to one team, so that the destiny is in their hands. It's not like federated across 3 different teams or 4 different or whatever it is. SOA definitely stuck with a lot of reusability part of it. Reusability is good, but it also created a lot of coupling within services. It's not, Microservice doesn't say that its reusability is not good, but to a limit. SOA also spoke a lot about governance standards. You have seen the proliferation or the rise of web services standards, WSStar, SOAP. If some of you have been part of the presentations yesterday, you will see like SOAP versus REST. So why not SOAP? I mean, we have gone through that pain point. Why not SOAP, and why we are trying to do REST? So microservices is trying to go away from these governance standards. It talks more about collaboration, what makes sense for your part. Keep it simple. That's the main thing. SOA also, it was the rise of ESB. There were like pipes. They were smart pipes, and what they say, smart pipes dump endpoints. We don't want that. We want smart endpoints and dumb pipes. ESBs did a lot of that because if you see messaging technology is not complicated. They built that technology 20 years back, and how can they sell the same thing over and over again? They have to build things on top of messaging so that people will buy it. But I mean, stay away from it. I mean, that's what it's trying to say. Containers, the rise of containers is microservices makes it more prevalent. It brings it into the forefront. So that is one definition. If you don't agree with anything of that, whatever I just said, I think if you have to put it, you can say like it's a SOA done right. SOA is a great technology, architectural, whatever you call it, paradigm or specification. It's great. So it's an opinionated way. Microservices is an opinionated way of doing SOA. And so it is SOA done right. Nothing wrong with SOA. You can still practice it if you follow the rest of the microservices principles. So what is the technical value? Why I should be using or practicing this part of this kind of architectural paradigm, right? So there are a few of them. I've broken down into two: technical value and organizational value. Bulk of it is technology oriented, but you will see the organization part, although it's small, but the impact is big. So we'll start with the technology. How many of you, while building your applications, you would have thought like, oh no, I don't want to use MySQL or SQL Server or RDBMS. I want to use something else. I'm pretty sure you would have come across those scenarios, right? But you had, like if you were in a monolith kind of an application, there might be, I'm just tagging it with SOA, the older legacy term. You would have thought about it, but you were stuck with it because some of those decisions were like mandated on you from different teams, like database teams, for example, would say, no, use only SQL Server. But I don't want to use it. So microservices tries to hit on that point. It says, okay, services, you own it, what they say, you own it, you build it. You build it, you own it, you maintain it, and all that stuff, right? So this is in your control. This is part of your destiny. So if I was part of MySpace. I worked in MySpace for a long time, which was kind of a social networking site before Facebook came over. A painful point. Anyways, so we had like different like teams. Like I was part of the Friends team, and there were other people part of the Posts team. So for me, RDBMS doesn't make sense. It's a social graph I have to build. I need a graph DB. So I will have my own database. I can just like that. I can control it. So that's what this means. So this microservices gives you that power to make that choice. Ease of deployment. Now, if you're in a monolith, like if you had a WebLogic big war to maintain and to deploy, any small change, you have to deploy the whole thing. It's like a big, it's like a task by itself to like promote into production or something like that, and you have to coordinate across so different teams. I have worked in financial companies, which I'm pretty sure financial healthcare. I mean, they're huge. I mean, to navigate through their system of deployment into production, like it's a task by itself. It's a project by itself actually. So microservices again tries to say, okay, make it small so that you can deploy smaller units. The surface area of risk reduces, which makes you much more agile. Time to market increases. Reduces. We are in the world of like various devices, mobile, wearables, web, other things. So you want to build microservices. Microservices, if you have the right granular microservices, it helps you compose all of them so that you can target a particular device, because the rendering and the UI is different. As I said, when I was in microservices, I was also part of their mobile team. In that time, like 2006-07 time, there were not good technologies. You want to render something on mobile, you have to do a lot of crazy stuff. You have to take the web, HTML, strip things out so that you are compatible to a particular device. Nowadays, I mean, it's much more easier because either it's iPhone or Android, and you have larger form factors. But the thing is, like, microservices helps you tackle that problem in today's world. Resilience, as I said, microservices don't simplify your space. It does complicate a bit, and this is one of them, because there are so many moving parts. So you want to make it resilient. In monolith, if it failed, you know where it failed. I can go there and most probably I'll troubleshoot. Over here, it is not like that, because there are so many moving parts. So if something fails, diagnosing that something failed, where it failed, and how can I fix it. So you have to use some best practices and some principles. So resilience is something which you always want part of an application. Some of the things like bulkheading, it's a concept taken from like ships. It has like compartments, so if something floods, you can close that compartment out, and the rest of the ship is stable. You will see how we can implement it. We'll talk more about resilience. Scaling, obviously you want to scale, but now you can scale specific parts of it. If you had a monolith, you have to scale the whole thing, whole application out. Even if, like as I said, like for the social networking application in MySpace, friends might be getting more requests than posts, for example. So you can selectively scale. You can scale friends. You don't want to scale posts. It makes your environment much more efficient in terms of servers, the provisioning of servers, the cost, and all that stuff. So put your money where you think there's more need. It's not like one size fits all. It gives you that choice. And as technologists, we always think, oh, I wish I didn't do this right. I could have used a different open source product or a client product or a paid product. I wish I could have refactored this code. With microservices, it actually helps you do that because, as I said, the surface area is small. You can take some risks. Obviously, don't take risks without understanding that these are the risks, or you know that I'm getting into trouble and still I'm going to take it. I'll talk about like how you can mitigate those things. But this helps you replace your services, your underneath applications, products more often. Gives you that comfort feeling. Okay, so organizational value is, we spoke about technical part of it. Organization, I mean, I'm pretty sure I have seen this organization structure in the past. Like you had, as I said, you had DBAs who take care of database, you had middleware specialists, you had UI specialists. And you can see like this creates a silo. So there is a famous law on organizational scale, which is called Conway's law. What it says is like, your technical design would kind of replicate your organization structure, which is not good which is good from an organization point of view, but it's not good from a technical architecture point of view, because now you're creating different components just because of this heck of doing it. And there's a famous quote like, if there are 4 different groups to build a compiler, you will get a 4-pass compiler, because everybody wants to get some work out. That is just, and it's not good. So microservices tries to hit on that from an organizational point of view, that don't do this. Try to align your teams and all this stuff based on your architecture, not the other way around, if you really care about technology. So this is the interesting part. So we will get into, this is my take and how I have implemented microservices in the past while I was in MySpace and currently, and before that I was in a big financial company, Credit Suisse. So before we get into like the architecture of it, we'll see, okay, what is in the space, right? What are the things you really need? We have gone through all of these stages in our development lifecycle. You go through a development, you have build, test, you have release, and then you have to manage, obviously. So when you're doing when you're doing development, the things you want to do is obviously you need an IDE, so you can use Eclipse or whatever your favorite IDE is, not a problem. Use Maven for your dependency management and all that stuff. I know nowadays there are other things, but that's what I've used. It works. Git, I think Git is a good version control tool. I've used SVN in the past. I've used other things, but I think Git is a good tool. Build, write unit tests. That is the key. So part of your development, you should be doing all of this. I mean, you should be using some of these tools to make a good microservices architecture for your development phase. Unit testing is very key. Use Sonar for code coverage and all that stuff. Because if you don't gauge the quality of your code, I mean, if you don't know what you're building, I'm pretty sure you won't know how to maintain it and whether I'm doing it right. So that is very key. Once you pass the development phase, you're getting into a build phase. Now I've written code, I've written test cases. Now I want to build it. I want to so use things like Jenkins, because you want to get into an automated mechanism. Remove as much as manual provisioning, manual testing. So use things like Jenkins. SOAP UI, you're part of this conference. So SOAP UI or Ready UI, you can build automation tests on top of it. You can fire it through Jenkins. Part of the Jenkins check-in is like, once I check in, build it, run the tests. You get to see there and then. So I check in code, I see like what is the state of my code base. So do that. Use Artifactory for storing your dependencies, libraries, and all this stuff. And if you really want to go, I mean, if you do these things right, if you have right automation tests, unit tests, do some of these other things, use Jenkins, you will have a good quality code. Because one of the things which I have not put over here is Sonar. You can put Sonar. Sonar is a good tool to get some of the metrics. If you do all of this right, I think you should be in a good place. If you go a bit further, a lot of companies nowadays are trying to have their end users, whether it's business analysts or end users, also test the system, because sometimes I've seen you miss some of the use cases, like end user use cases. use Cucumber, which is part of kind of, they say like part of the BDD, Behavioral Driven Design, testing or whatever, development, whatever the acronym is for. Use Cucumber if you really want, part of your release. So once everything is done before you release, let the users give you unit tests, give you tests, and you can just run it part of the release cycle before you actually package and go through the rest of the things. Obviously, this is part of the development, but you also need to manage things. How do you manage? Because microservices, you're trying to create multiple services to scale things and all that stuff. Docker is a pretty, I mean, there are other things, but other competitors, like for a container-based architecture, Docker, I feel, is pretty mature and gives you a lot of power. Kubernetes it helps you manage because now you have a lot of services running in different VMs or hosts. You have to manage them. Kubernetes is another component which you should be looking into. You have to monitor logs because now you have to troubleshoot. You might have to troubleshoot things. You want to see what is the health of the system. Those days are gone where like you can do a top and people are just logging into multiple terminals. I mean, you have seen, it's like metrics, multiple terminals, and people are trying to see, okay, which one is going bad. I mean, it won't work. Microservices architecture, it won't work. So things you have to consolidate logs and metrics and all that stuff. So ELK stack, you can replace these with anything else, but this works. You can use Splunk if you have Splunk. Splunk is a great tool. I've used it in the past. It is absolutely great. The other tools like for aggregation, like Graphite, you can monitor things through Nagios or Ganglia or something like that. So you need mix of this for each of the stage. Like what I'm trying to say is you need tools. You need tools, embrace them, use them so that you can remove the manual part of it from your process. This is kind of a high-level architecture which I'm executing currently and I've executed in the past. So if you want to really get into microservices architecture implementation, there is a good open source library or framework you can call, which is called Jhipster. There are other replacements for it, but I think that is a great product. It gives you a lot of plumbing. You get out of the box a lot of things. So this is kind of this is part of the Jhipster architecture. You can replace components. You can build plugins to modify your structure, the code. It's kind of a code generator at the end, but it gives a lot of other things too. So this is part of the reference architecture, which I have done, as I said. So what happens is, I'll just move over here. So we are building microservices because you're trying to scale them, so you will have more than one. Once you deploy, what it does, it registers itself with a server, and this comes part of the Jhipster framework. So it registers, it uses a lot of Netflix's open source software, Eureka, this part of Spring Cloud. So a lot of whatever I'm talking over here is all free. Okay, I'm not spending a dime to create this architecture. Console is a paid, so that's an option, but you might not use it if you don't want to. So the registry gives you service registration and discovery for your microservices. So you can use that. You can version, because most probably if you mess up something, you want to go back to a previous version. So it will use Git automatically. I think you can replace with something else, but Git works. It doesn't have to be a server. It just needs to be a local instance, so it's not a problem. So it registers. It tells, OK, this is the service. This is the name. This is where I am. Then if there is an Angular app, you have an Angular app, you have load balancing and all that goodness. So load balancing and proxying through Zool proxy and Ribbon, it takes care of that. So if there's Angular app you build on top of it, which is part of the gateway, your request comes in, you see, OK, this is the service I need. So your Angular app tries to go across 3 different microservices. You might say, OK, these are the services I need to talk to. It can discover it through the registry, OK, where the services are in a load balanced fashion. It's not fixated into a particular endpoint or a server IP. So it will discover it, pick something at random. Most probably that's what the implementation is. Might be something different. Never digged into that detail, but it'll pick up some service. It'll call it. It'll get the response back, and it'll process it and send it back. Access control, obviously part of the call. Obviously, you need authorization. You can do OAuth, you can do LDAP, AD, most of it. You can use tools like what I use to make that simpler. there is other open source tools like Pack4j, which gives you a lot of plumbing out of it for you integrate for the authentication part of it. So you can use that. You can also replace it with your own like role-based access control component if you have. That's what I'm doing currently. I'm not using that because OAuth is in beta part of this framework, but we already have an RBAC system in our product. So I'm going to replace that with, or I'm replacing that with the access control over here. Now you have deployed it. The things they are running. The app is able to discover in a load balance, scalable manner. Now I need to manage for DevOps, for support. They need to somehow make sure that the servers are monitored. As I said, nobody would log into each machine and see top and log into each file, log file, and try to see what is going wrong. You need a way of integrating or aggregating all of that. So you can replace that with anything, but again, Jhipster has actually a reporting console if you really want to use that, but you can use any aggregating mechanism. You can push it into, as I said, Splunk through the appenders, or you can use ELK stack, Elasticsearch for storage, Logstash obviously for pushing the data, and Kibana for visualizing it. So this is what it is. If you have any questions, we will have time, so we will go through it. Just hold on to it for now. Okay, as I said, for any architecture, you need some principles so that you know that you're doing it right. So quickly going through it, microservices architecture is based on because you want to know like how a micro is. There are some guidelines like domain-driven design. This again not a new concept. It has been there for a long time. Because what it says is like if you have your entity, your objects, or your business domain objects. Depends on what context they are in, and that should be part of that service. They should not be together. For example, a customer, if you're in an e-commerce application, you have a customer. Customer is a pretty common thing. So part of the order, you have some properties, delivery. If you're delivering this, you need a customer info, an object, you have address and something else. And if you're billing, you have some couple of more different properties. So instead of having all of them, the customer as a big object, one of the things microservice all talks about is don't have God classes. When you have God classes, that means, as the name says, they are big, they are God, they control a lot of things, they suck responsibilities from other people or other components, so that's not good. So break them out, break them down, and put it part of the, so you can read this book. It's a pretty good book, Domain-Driven Design by Eric Vance. You will get to know a lot of other things. This is just an example. It shows like it's a part of the orders application. There are two APIs, as you can see, customer API, but they're getting two different things. Automation is very key. As I already spoke about it. So use automating for continuous integration for images or building VMs and provisioning and all that stuff for your machines. Use Docker, Vagrant. For monitoring, aggregation, use ELK stack. For automation, use RedUI, SoapUI. Git for that for version control, Swagger for your APIs, because you will be building APIs on top of it. So you would need some things. You will see that's also a principle. So encapsulation is pretty key. I mean, we have studied about it. In monolith, like you would have one database and a lot of other services most probably will be coming and talking to it. What it says is like microservices say, don't share your database because data is not. If you don't share the data, if you share. So assume you share two different services talking to it. So one schema change would impact two different services, which is not good. So don't share your data, encapsulate that as much as possible, and aggregate it in the UI. Nowadays, with the UI technology, you can aggregate things, and it makes your application much more better. Autonomy, self-service. As a developer, give the power back to the team who is developing the application. Previously, you had sysadmins and all that stuff, all those separate groups. Go away from it. Use things like Vagrant, Docker. So give the power back to the team. As I said, like if you build it, you want it, and this is very key. Again, previously you had things like you had smart pipes, dumb endpoints. Reverse it. Don't use like big ESBs. You don't need it. You just need a simple like Kafka or ZeroMQ or something like that for your messaging. Give the power to the services. You should be able to deploy independently. So in the past, like you used to have processes, like one process can have multiple services. but that's not recommended because a bad process can mess up with your process, not from an address space, but from the CPU, because it can hog into the CPU and you are deprived of it, starvation, all this stuff. So it's recommended to have a service running on each process. Now, as I said, APIs. So you should be having consumer-driven contracts because it's very key. You want to make a change, as I said, you want to be agile, you want to make a change, but you don't want to break somebody else because then it's of no good, right? We have gone through that pain point before. So have consumer-driven contracts. One of the things is like if you, just versioning, so running out of time. There are different APIs, tools which you can use. You spoke about service discovery, some of the principle. You have to isolate failures, use bulkheading, or use circuit breakers. There are tools for it, like Hystrix for circuit breaking. You can do that. So then comes to monitoring and maintenance of it. Spoke about log aggregation, stat aggregation. If you want to correlate the whole run of the service flow, you can use things like Zipkin to do that. Part of the organization, as I said, like it's part of the culture. So you want to create a team which maps to the architecture, not the other way around. Once you do that, once you get into what they call concept called psychological safety, it's like a developer making a change so that and be confident that I can make the change, I can push into production. So that will come if you practice the principles. Developers are much more, the technical team is much more empowered to make choices, make decisions, make like strategic calls and do it. And is everything good with this? As I said, is everything awesome if I do it? Is it the silver bullet? Answer is obviously no. I mean, if you think you're not in the phase to practice microservices yet, that's fine. Start monolith. Everybody started with a monolith. Netflix did, Amazon did, everybody else did. But start investing in some of the things, like start aligning your teams to service architecture. Try to understand your business domain. Try to model your services around it. Do infrastructure automation, use Docker, Vagrant, other things so that you can do things automatically. Automated testing, continuous delivery, API design, and all that. So at least start making an effort in that paradigm, because in my opinion, this is the technology of the future. This is a good paradigm to move into to build good, smart, and agile software. Thanks. I hope it made sense. How much time?